Hi guys, this is another Smartphysics tutorial, and today our problem is the power in an AC circuit. Okay, here's our beautiful circuit. It has a generator, capacitor, resistor, inductor. They gave us the maximum voltage for the generator. They gave us the omega. They gave us the inductance actually, and these are unknown. And the phi, and the power delivered to the circuit by the generator is 73, which is P average for the generator. Okay, so the first question it's asking, what is the I max? Okay. Well, we can use the fact that they gave us the power average by the generator, and so power average will be equal to half I max times the max times the cosine of phi. Let me use this one. Okay. So we have the I max, we have the cosine, we have the P average, so we're just solving for the I max. So look from here, I max will be equal to 2 P average divided by the voltage max for the generator divided by the cosine of phi. Okay, and you'll get the I. Okay, for this one I got 1.62. Oops. Okay, for number 2, they're asking what is R, the value of the resistance in the circuit. They want to know R. Okay, so how do we go solving this now? Okay, we have the cosine of phi equal R over Z. Okay, alright, how can we find the Z? The Z is the impedance of the circuit, so just divide the voltage of the generator divided by the I max. We have this, and we got this from this. This is the answer for this, so divide the voltage of the generator by the I max, and we get the Z. And then the value of Z, plug it in back here. So the R is cosine phi times C. Okay. Right, so question number 3, they're asking what is C, the value of the capacitance of the circuit. Okay, so let me draw the diagram for the phasors here. So we know that the current lead the voltage of the generator. That means that the voltage starts, if you look back here, at time equals 0. It's starting at 0. So let me use this. So here is the voltage, and then the current is leading it by 44 degree. Okay, here. Oh, this should be shorter than this, but anyway. And the what do you want to say? Okay. So this is going. This is the VR, VL. This one is the VR, and Here's the VC. Okay, so this is the 44-degree angle. Okay, number 3, they're asking what is the capacitance. Right, so we can use, if we know that, I should draw this longer. This is X minus XC. But if you look here, the VC is bigger than the VL. That's why the voltage is going down. That's why that's why the current is leading the voltage here. That means that the voltage of the capacitance is more than the voltage of the inductor. That's why the angle is going down. Like if you draw the one with the Z thing. So here's the current. Here's the I. So the Z is going like this. And this is like actually XC minus XL. Okay. So we have this 44-degree. So we have, this is the R. This Z is here. So we can use the tangent of phi equal the XC minus XL over the R. And the value of R, we have it from the previous question here. Okay, so XC will be equal to R tangent phi plus XL. And then, so this one is 1 over C equal R tangent theta plus omega. So just take this down. So the C will be equal to 1 over omega R tan phi plus L omega. Okay. Here's the capacitance, and make sure you do it in microfarad, because that's what the question is asking in my case. Okay. The third question is asking what is the value of omega. I mean, the value of omega is now changed, keeping all the other circuit parameters constant until resonance is reached. How was omega changed? Okay, well, you can do it in 2 ways here. You can do it like if the omega at resonance is 1 over omega L C, and find this value, and then see compare it to the one you have from the question here. Okay. For this one I got 617.09, which means mine was 456, which means it was increased. So the omega increased here. This is red per second. Or you can see that the VC here was bigger than the VL. Okay, and in order to be at I don't know how to say resonance, the angle between those should be 0, which means that the XL minus XC should be 0. And to do that, we need to increase the omega, because when you do the XL minus XC, this is L omega minus XC. If this is bigger than this, then the omega should increase, go up, in order to be equal to this. Okay. Well, but use this way, it's more accurate. So this is 4. And number 5, it's asking what is the average power delivered to the circuit when it's at resonance. Oh, I'm saying it right now. Alright, cool. So the power delivered to the circuit is equal to I ms RMS then cosine of theta. Okay. So when it's at resonance, this cosine is going to be the z will be equal to r. So r over z, which is 1. Okay. So this one is 1. That's why it's maximum at the resonance. Okay. So the I max divided by square root of 2 times the max square root of 2 times 1. And this is power delivered. Let me give you values for this. For the I max divided by square root of 2, I got 1.19. Then multiplying it by 84. And for this guy, I got 100.97 watt. Well, this question, I'm not sure of it, so because it's a time question, it doesn't tell me if it's right or wrong. But that's the way I did it. If I see that it's wrong, I'll get back to you and tell you somewhere here. I'll put a comment here. Alright, I hope this helped and good luck.